Welcome back to the Punny Math Teacher. So we are on our last lesson and it's going to be a PDF. So it's going to be kind of funky. So if you want to, it's backwards I know, but it's called Scatterplots and Lines of Best Fit. It's just a PDF. So it's not really going to be in our notes, but if you want to print it out and write on it along with me, you're welcome to. We'll see if I type. I haven't done it yet. We'll see how this works. So remember, you can always pause if I'm typing weird, just like fast forward when I finish typing. That works as well. So our last thing today is making applications of everything. So we're going to apply all three forms of our linear equations to create functions for real-world contexts. And I want you to understand why we even want functions, like what's the use of them. So the PDF is here, and I will be attaching it. I guess I'll attach it. Maybe I'll attach it to the my posting. We'll see. I don't know. I don't remember where I got this picture. I think it's from a random online textbook that I Googled, and I've just used it ever since. I've created the worksheet, so it is all my own work besides the picture. But you could use this for any graph that you want as a scatter plot. So this is a scatter plot because it's all scattered and there's points that you've plotted on it. Imagine that. So these are real sandwiches on some guy's menu. So at, like, if you were reading this at 10 grams of fat, that means your calories are about 425 calories. At around like 39 grams of fat, it's a little over 600 calories. So that's how we can read this scatter plot. So to reinforce how you read it, how many calories are in a sandwich that contain 17 grams of fat? If we look at 17, that should be at 400. How many grams of fat are in a sandwich that contains 600 calories? So going backwards, if you're at 600, it'll be 30 grams of fat. What tends to happen to the number of calories as the number of grams of fat increases? Remember, we read graphs from left to right, so you can see it increasing. As number of calories increases, or as number of fat grams increase, then the number of calories increase. And on the back side, because this is a 2-page PDF, and we'll explore that a little more as well. So what if a sandwich has 20 grams of fat? So this one's actually not on here. There is no sandwich that's 20 grams of fat. But if we assume this imaginary sandwich, or Carl, whoever owns this, I made up Carl, why not? Carl wants to make a new sandwich for his restaurant menu that has 20 grams of fat because there's nothing at 20. It's a missing area, missed opportunity. How many calories should he be shooting for? It's up to you. As long as it's in this kind of range area, then you'll be fine because it fits the pattern. All right, that's what explaining your reasoning is there for. So why would you pick 20 and 450? Why would you pick 20 and 500? Both of those are fine. Why would you pick 20, 475? Why would you pick 20, 425? Would you pick 20, 300? Would that follow the pattern? Would 20 and 800 follow the pattern? Okay, so is there a line that could best fit the data? Why or why not? Well, this trend does seem to be linear. So if I took a line, which I guess you can't see, let's try this. Can I click this button? And if I click this button, okay. Imagine that was a straight, I did it for me! It's so great! You're so great! Okay. For a second, I was freaked out that I didn't actually have this recorded. So, woohoo, it's recorded. I made a straight line. Whoop, whoop. Okay, that's a line of best fit because it's approximately in the middle of my data. You could have yours a little bit higher. It's totally fine. But your goal is to get it to be a best fit of the data. Part F, we sketched the line. Now we got to write an equation, which we've done this. Because point slope form, all you need is a slope at any point. Okay, or just 2 points. So if we can find 2 points on this graph, we can write it in point slope form. We can write it in slope and intercept form. We could convert those into standard form. You can write it in any way you like. You have the tools. So pick any 2 points, figure out which form you want to write it in, write it down. So I'm not actually going to tell you the answer because your answer is totally different than my answer. I'm just going to go over steps. Use your notes to figure out the rest. Okay, whoop, whoop. So using the equation only, so notice that on our equation, your x is going to represent the number of fat grams, and your y is going to be the output, because if you input the number of fat grams, how many calories will come out? Calories is your output. So knowing that, if you have 20 grams of fat, that's going to be your x, your inputting. So in your equation, plug in or substitute in, replace that x equals 20, solve it for y, and that's how many calories your sandwich with 20 grams of fat, according to this line, will produce. So according to my line, it would be 450. Okay? And then moving on, compare your answers D and G. So what was your assumption from just looking at the graph? What was your prediction? And then on G, what was your actual mathematically proved answer? And comparing those, are they the same? Because sometimes they actually are the same. Are they different? And why? And which do you think is more accurate? Do you think your eyeball looking at it is more accurate because you saw the whole pattern at once? Or do you think your line's more accurate because it's going through the middle of the data? There's no right answer as long as you back it up. And back it up mathematically with logic and reasoning. So then number 2. So we're going to go over correlations because we have a positive correlation of fat grams and calories because it's going up and at a positive, it's looking like a positive slope, so it's called a positive correlation. If there's a negative slope, it's negative correlation, and if it's just scattered all over and you have no pattern, it's called no correlation. So you have graphs on the right-hand sides over here. Make sure your time, so year is on your x-axis, smoking is your y-axis, temperament, or height versus temperament. I have no idea what scale they got this data from. I think I got it from Stat Trek or Stat Crunch. I don't know. One of those is a great thing to go Google, and they just have data sets out the wazoo, like anything about cereal and superheroes and baseball. Like they just have data from everywhere, and it's awesome. So I got that data from there. I have no idea what scale they got the data temperament from, but height in inches, and then year and skim milk consumed per person in pounds per year. So in 1980, each person approximately, because some people don't drink milk, but approximately in 1980, each person consumed 26.9 pounds of milk, well, skim milk, a year in America. Yay! So your x-axis is year, your y-axis is skim milk. Think about what scale you should use to maximize the graph. You don't want to just use a little tiny corner. You don't want to go beyond the graph because then it's not accurate because it's not spaced out, right? So make sure that you know the minimum to the maximum, and then draw a line of best fit that you can. If you want to practice making the equation, great, go for it. And then, see what kind of correlation it is. Which one's positive, which one's negative, and which one is no correlation, because I don't remember which order they're in. But once you draw them, you'll get it. And if you have questions, then just go Google correlation and it'll find more examples there as well. So, we already did that. There's a comprehension questions. So why do we prefer functions? Like, what's the goal of a function? If it helps, go back and look at number 1, parts D and G, and compare them. And H, I think, was the question that when did you compare them? So compare an H back to that comprehension question. Google interpolation and extrapolation and see what do they mean and how do you use a line of best fit or even a scatter plot to actually find them, or how are they useful? Which one's more useful than another? And which one is a function better for, depending on the real world situation. And that should be about it. Alrighty, have a great day. And this scatter plot sheet will also be in my Teachers by Teachers whenever I get around to finally putting everything in there. So, yay! Have a great day. Thanks for watching, and see you later. Bye.